Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, friends, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love when we get together on Wednesdays and just do a little bit of math. I am repping my Mickey Mouse sweatshirt tonight because I am obsessed with Disney World. We don't go very often. I know most people think like, oh, you live in Central Florida, you must go to Disney all the time. There are some people that do. We do not. We don't have passes or anything like that. But my little one is like at an age where it's just so fun. And so I can't wait to take him to maybe like one of the parties or something like that. So Mickey Mouse for life. Like Dr. A said, we are here every Wednesday just solving math problems that are to help you be more confident and more competent in your skill set for your upcoming math exam. So without further ado, let's go ahead and in the comment box, let me know where you're from. What test are you prepping for? And have you ever been to Disney? Disney World, Disneyland, Disneyland Paris, Disneyland Hong Kong. Have you ever been to Disney? My favorite park is probably Animal Kingdom or just the Magic of Magic Kingdom, but probably Animal Kingdom. So where are you from? What test are you prepping for? And have you ever been to a Disney park of some sort? Like I said, I think Animal Kingdom would be my favorite, Magic Kingdom. But I do love Epcot and Hollywood Studios, so that would be a hard decision for me. We are going to go over about 10. I never get through 10 problems. Let's not even say we're going to go through 10 problems. We'll probably go through like 8 problems. And I always have a next week section where I like to get what you guys are trying to work on and add it to my list here. So let me know what you're struggling with. I have geometry on here from last week. I have comp 3 for the GK from last week. I did not specifically get a chance to add those in. There is some geometry in this week's set, but I didn't have a chance to like pinpoint those specific things. And then I have more of problem number 3 from last week. So as you're studying, as you're watching tonight's video, as you're, trying to figure out like what is helpful for you, what do you want to see, let me know in the comment box and I will absolutely add it to the next week list because these sessions are for you. Yes, I love doing them, but these sessions are truly for you to be able to gain something out of it. And so let me know in the comment box what you're studying, what you're prepping for, what you want to see more of. Ask questions tonight because that is how you learn, is by asking questions. So just let me know in the comment box how I can best serve you, how I can best help you through these sessions, and we will go ahead and get started with our first problem. Problem number 1. This is definitely for like a pre-K through 3, K through 6, and you'll see why in a minute. A teacher is introducing the concept of place value to 3rd grade students. Which of the following activities would most effectively help students understand the value of digits in a 3-digit number? Which of the following activities would most effectively help students understand the value of digits in a 3-digit number? Providing students with worksheets that require them to solve multiplication problems. Using base 10 blocks to represent hundreds, tens, and ones in a 3-digit number. Asking students to memorize the order of operations for solving equations. Or showing a video about the history of mathematics. So some keywords that we're looking for, because these are the kinds of problems that our brain gets overwhelmed with because there's a whole lot of words. Your brain is tired when you're taking these kinds of exams because the stamina that is required for these kinds of exams is long. And so we want to be able to break this apart. The teacher is introducing, that is a absolute key word, and you'll see why in a minute. The concept of place value to 3rd graders. Okay, so that establishes what we're doing. Introduction of place value to 3rd grade students. We're not introducing place value to 5th grade students because if we were, we would be looking at decimals and stuff like that. We're not introducing the concept of place value to 1st grade students because if we were, we would be looking at a little bit of a different place value. We are introducing place value to 3rd graders. Which of the following activities would most effectively help students understand the value of digits? Not most effectively understand 3-digit numbers, most effectively understand what that value is. Let's go on a rabbit trail and talk about the value of the digits. So if I have the number 289, because if you don't understand this concept, you're not going to understand what this problem is asking. 289. 289 is bigger than 172, is smaller than 324, right? Like we can reason with that. But what is the value of the 2? The value of the 2 is not 2. The value of the digit 2 in the number 289 is 200 because it's sitting in the 100 spot. And so the 2 has a value of 200. The value of the 8 is 80. The value of the 9 is 9. So which of these is going to help the students understand the value of the digits in an introduction? Well, when we're talking about the introduction of a concept in mathematics, regardless of whether it's place value or anything else for that matter, students process in a concrete, then pictorial, then abstract. That is the best, most effective research-based way to introduce mathematics, no matter whether they're in kindergarten or calculus. They absorb content concretely. Then we move on to the pictorial representation and then the abstract representation. And so when we're looking at the value of digits and we are introducing them, we want to provide them with a concrete model to do so. So providing students with worksheets already tells me that is absolutely not the correct answer, because that doesn't offer them the opportunity to practice concretely, introduce concretely. That is an abstract way to represent stuff. B, using base 10 blocks. Right there, I already know that I'm concretely representing something. Manipulatives, blocks, anything like that is going to be a concrete representation. But let's keep reading that to make sure that we are concretely understanding the value of digits and not concretely doing something else, right? So using base 10 blocks to represent hundreds, tens, and ones in a 3-digit number. Ding, 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 ding. We have our answer, but let's keep going and looking to make sure that we don't have a better option. Asking students to memorize the order of operations for solving equations, that's not even related to this kind of task. And showing a video about the history of mathematics is not related to understanding the value of a 3-digit number. Hence, why B is the correct answer. Let's go ahead and move on to the next problem. A 3rd grade teacher is reviewing subtraction problems. One student solved the problem 78 minus 29 and wrote the answer 59 with the explanation, I just subtracted the ones place and then the tens place. What is the most effective way for the teacher to address this student's misunderstanding? Explain to the student that their method is incorrect and provide the correct answer along with a new subtraction problem. Ask the student to recheck their calculation and compare their answer with a calculator. Show the student the correct way to perform the subtraction using a step-by-step method and model using pictures or more algorithmic models if necessary. Model the problem by showing the student how to borrow when subtracting. Give the student more practice problems with similar errors to see if they can correct themselves over time. So this is a problem. So the other problem, it had a more clear answer. This problem definitely has multiple answers that we could sit in a room and argue which one is the most effective. There is a most effective one. However, there are methods that are listed here that are commonly used in classrooms that could be or could not be argued as to whether they are effective or not effective. And so this one is one of those really difficult problems because it's one of those problems where you're like, oh, is it this one or is it this one? So the goal is to be able to narrow it down and then think like the test takers. That's the goal. Think like the test takers. So again, we're going to look for those key words. We're going to look for those highlights in this problem. So they're reviewing subtraction problems. A student solves this, and they're asking what is the most effective way to do what? To address the misunderstanding. That is a key piece of this problem. The most effective way to address the misunderstanding, not the most effective way to build confidence, not the most effective way to build fluency, the most effective way to address the student's misunderstanding. So the first thing we want to do is really kind of see where that misunderstanding is. So 78 minus 29. And the student said that they just subtracted the ones place and then subtracted the tens place. So when we subtract the ones place, we really can't, because we can't do 8 minus 9 without landing in the negatives, right? And so we have to regroup. So this becomes this. So we do end up with a 9, and 6 minus 2 is 4. So what does it look like the student's error was? It looks like the student may have known to regroup, but then forgot to make this, like, to regroup that 10. And so the 8 became an 18 by regrouping, but then the 7 stayed a 7, or something of that nature. The student also could have just not known what to do here, and so they just wrote a 9 because that's the best that they could do, and then did 7 minus 2 is 5. We really don't know which of those two methods the student used, because we didn't have a chance to ask them for a deeper explanation. So show me how you did the ones, right? That is always going to be the better way to understand what the student's misconception is. So if this said, what is the most effective way for the teacher to understand the student's misconception, we would want to ask clarifying questions so that we really could dig deeper into what the student was doing. But at this point, we are in the addressing the student's misunderstanding. So explaining to the student that their method is incorrect and providing the correct answer along with a new subtraction problem. Not bad. Let's keep moving. Ask the student to recheck their calculation and then compare their answer with a calculator. In that sense, we're not addressing the student's misunderstanding, because we're not looking for the root cause of that error. And then we're relying on the calculator to just give them a right answer. So if the student rechecks and they think that they got it right, and then they use a calculator and the calculator says that the answer is 49, we have not addressed that student's misconception at all. In fact, the student's probably just going to write 49, move on. And when you ask them if they get it, they're going to say yes. That is often how those kinds of scenarios work. And so that's not going to be the right answer. Show the student the correct way to perform the subtraction using a step-by-step method, and model using pictures or more algorithmic models if necessary. That sounds very similar to the letter A, where we're explaining to the student that they were incorrect. So let's keep C as well. Model the problem by showing the student how to borrow when subtracting. That sounds very similar to A and C as well. However, D is wrong because we're using the wrong vocabulary. We are absolutely not borrowing anything. We're not going to give it back. And that's what I need you to recognize, because borrow is such a popular word to use when we're talking about subtraction, where we have to go across multiple place values. And being precise in our language is important, because what we're not doing is we're not borrowing something and then giving it back. We're regrouping, which means we're taking the group of 10s that we have and we're literally regrouping a 10 into 10 ones. We're changing its format. We're going from a 10 to 10 ones, and we're going to leave those in the ones section. We are not giving it back, because if we were giving it back, if we did 18 minus 9 and then gave it back, we would actually end up with 59 as our answer, and that's not the correct answer. And so it's important to recognize when language is not accurate. And this is one of those situations where that is not the correct answer, because we're not going to borrow anything. E, give the student more practice problems with similar errors to see if they can correct themselves over time. That is definitely not the most effective way to address that misconception. Oftentimes, errors like this are not going to correct themselves because the student doesn't realize that they're doing anything wrong. So they're going to, if you tell them, go ahead and keep practicing, keep doing more problems, they're gonna have a confidence boost, which is great. We want them to be confident in math, but we also want them to be confidently correct while doing it. We don't want them to keep practicing incorrect, because all that's going to do is bury that misunderstanding further and further and further. And that's definitely not what we want. We don't want them practicing wrong multiple times. So A and C, what is the difference? A, we explain to the student that they are incorrect, basically, and then give them the correct answer, or show the student the correct way. Show and explain are two different verbs, and I want you to notice the slight, subtle differences. explain to them that they're wrong or show them the correct way by using that step-by-step method and modeling using pictures or the more algorithmic models, depending on what that student's needs are. So it's important to realize those subtle differences because that's going to be the make or break between A and C in this kind of situation. And that is why, my friends, C is the correct answer. Now, I will tell you, my comments are not working right now. And so, I'm not able to see what you're commenting if you're asking questions or something like that. This is a pre-recorded episode. And so usually we are live, but there are very few times where I still want to give you the help and the support that you need, but it just something happens or something comes up. And so this is a pre-recorded episode. So I'm not seeing your comments live right now. However, I promise you that I do go back and I look to see what comments you have, what questions you have, so that I can address them the following week when we are live back together. So I cannot see your comments. They're not working because we're not live right now. We're not actually together. However, I'm going to still be solving math problems. And so if you have questions, keep putting them in the comment box. But normally I'm good about answering questions on the spot. And so if I'm not answering your question on the spot, that is why. Let's go ahead and move on to problem number 3. Which of the following geometric solids has 7 faces, 7 vertices, and 12 edges? Which of the following geometric solids has 7 faces, 7 vertices, and 12 edges? A triangular prism, a pentagonal prism, a hexagonal prism, pyramid, or a rectangular pyramid? This is a really fun one. Here's why. Understanding the difference between a pyramid and a prism is important. So let's just do a little pyramid versus prism activity. So a pyramid has 2 identical bases, while a prism only has 1 base. Both of them are named based on the base. So they are both named based on the base. A pyramid then has rectangles connecting the 2 bases, and a prism has triangles extending from the base to connect at a point. So if we imagine this, if I have a triangular pyramid, I have 2 identical triangle bases. A triangular pyramid has, or a triangular, wow, I just totally flipped those up completely. This is not a pyramid and this is not a prism. This is a prism and this is a pyramid. Sorry about that. Some of you were probably like, oh my gosh, that is totally wrong. So if I have a triangular prism, I have 2 identical triangle bases, and then I have rectangles connecting those bases together. One of the most common interpretation errors is that people think that this is the base, and that even though that is what the triangular prism is currently sitting on, the way I drew it, that is not the base because it's not the 2 identical bases based on the name of that prism. So this is a triangular prism because we have triangular bases. This would be a triangular pyramid because I have a triangle base. And then I have triangles extending to connect my base at one point. So triangles extending from the base to connect at one point. So when we conceptually think about the number of sides or faces, a prism is going to have two bases plus the number of how do I say this? Rectangles and the number equals the number of sides of the base. So I have two triangular bases plus three rectangles because a triangle has three sides. I think that's the best way to describe it. And so if you're trying to quickly figure out how many faces a prism is going to have, the easiest way to do that is to just do that very simple math problem where you always have two bases and then you just add the number of sides of your base. So a pentagonal prism is going to have two bases plus 5 because a pentagon has 5 sides. So it's going to have 7 faces. The number of vertices is going to equal 2 times the number of vertices that one shape has in a prism. So a triangle has 3 vertices. 3 times 2 is 6. So a triangular prism has 6 vertices. A pentagonal prism is going to have 10 vertices. So we have not reached a conclusion yet for a shape that has 7 faces and 7 vertices. Let's keep going. In order to figure out the number of faces of a pyramid, you're going to have one base plus triangles, and that's also going to equal the number of triangles equals the number of sides that you have. So a pentagonal or a hexagonal pyramid is going to have one base plus 6 triangles equals 7 faces. The number of vertices is also going to be that exact same formula because you're going to have your vertices on the bottom, so 3 in a triangular pyramid, plus just 1 on the top. So you're going to do the 1 plus 6. So the number of faces equals the number of vertices in a pyramid. So a hexagonal pyramid has 7 and 7. A rectangular pyramid is going to have 1 base plus 4, which is 5. So I don't even have to calculate the number of edges because I was able to figure out the number of faces and vertices in all of my shapes. And the hexagonal pyramid was the only one that had the 7 and the 7. Does that make sense? All right, let's go ahead and move on to problem number 4. Y'all, this is a fun one. Mr. Ballard surveyed 120 first graders and asked them what their favorite color was. He constructed the following pie chart. How many more students preferred blue than purple and orange combined? How many more students preferred blue than purple and orange combined? Round to the nearest whole if necessary. So here's what we have to look at. we have to look at the fact that he surveyed 120 first graders. And the question is asking how many more students preferred blue than purple and orange combined. How many more preferred blue? That means more kids preferred blue. How many more? We have to subtract. How many more? We have to subtract. But we know blue has more, so I'm going to figure out the number of kids who chose blue, and I'm going to subtract the number of kids who chose purple and addition the number of kids who chose orange combined. So I have to figure out the purple and the orange and then subtract that from the blue. Well, I'm not just going to do blue, which I should use blue instead. This is the blue, this is the purple, and this is the orange. I'm not going to do 6.6 plus 5.8 and then subtract 37.5. Why? Because these are percentages. These are percentages, and I need to know the actual number. And there was 120 first graders. If I add all of those percentages up, I'm going to get 100% because it's a pie chart. That's how a pie chart works. I need to figure out what 37.5% is out of the 120 first graders. So how do I figure out what is the percent of a number? Multiply, exactly. Now, I'm not going to multiply 120 times 37.5. Definitely not, because I have to convert that percentage into a decimal. So I have to, there's a whole lot of lessons in this one problem, right? So if I have 37.5% and I'm going to convert that into decimal form, how do I convert percent into decimal? Hop that decimal 2 places to the left. Now, you might be able to tell me that 42% equals 0.42. And you might be able to tell me that 53% equals 0.53. But when we start throwing decimals inside the percent, that's where people start getting a little hazy in conversion. Don't do anything weird. Just take that decimal, hop it 2 places to the left, and it gives me 0.375. I'm going to do that process for blue, purple, and orange. I'm not going to do it for red and pink because they didn't ask me anything about red and pink. But I am going to do it for blue, purple, and orange. So this is blue. This will be purple. And this will be orange. So purple was 6.60%. Be careful. That does not equal 6.60% does not equal 0.660. That will be the number one error that people make on this. And then the orange is 5.80%. And so when I convert those, when I hop that decimal, I'm going to hop, and my decimal goes there, which means I need a 0 where I have an empty gap. And I'm going to hop, I need another 0 where I have that empty gap. So this equals 0.066, and this one equals 0.058. Now what am I going to do to figure out the actual number of kids that chose blue, purple, and orange? Multiply times 120 times 120 times 120. And I'm going to use my calculator for this one. So 0.375 times 120 equals 45. So 45 students chose blue minus purple and orange combined. So 0.066 times 120. That equals 7.92, but it says round to the nearest whole. So instead of 0.792, that rounds up to 8. So I'm going to write an 8. And orange combined. So 0.058 times 120. That equals 6.96, which rounds up to 7 because that 9 tells us to round up. 8 plus 7 is 15, so I'm going to do 45 minus 15, and that gives me an answer of 30. Questions about that problem? All right, let's keep going. James has $10.95 in nickels, dimes, and pennies. He has an equal number of nickels and dimes. If he has X nickels, which of the following represents the number of pennies he has? If he has X nickels, which of the following represents the number of pennies he has? All right, I'm not going to read those answer choices aloud because they're a little bit chunky. So we know that nickels, watch how simple this is. Nickels plus dimes plus pennies equals a certain number, right? Equals a certain number. And we know that 0.05 nickels plus 0.10 dimes plus 0.01 pennies equals $10.95. And you're like, whoa, how did you get that? Because I know that nickels equal 5 cents a piece, dimes equal 10 cents a piece, and pennies equal 1 cent a piece. And so if I figure out how much money I have in nickels, how much money I have in dimes, and how much money I have in pennies, it's going to equal $10.95. But I also know that the number of nickels and the number of dimes is the same. And so I'm going to, instead of N and D, I'm going to replace those with X's. Because N equals the number of nickels, D equals the number of dimes, and if they are the same and X equals the nickels, then X also equals the dimes. Let's keep going. 5 cents plus 10 cents is 15 cents, X, because these are now like terms, so I can combine them. Plus 1 cent penny equals $10.95. And now all I need to do is solve for the number of pennies. Get P by itself. Subtract this from both sides. Remember, whatever you do to one side, you have to do to the other. So I'm left with 1 cent penny equals $10.95 minus 0.15x. And then to get penny by itself, I divide both sides by 0.01, which means C is the correct answer. That, y'all, was a fun problem. And if you're not sure how to do that, I would rewatch that explanation because as I explained it, I bet your brain was going, oh, it all makes sense now. Let's go ahead and move on to problem number 6. Which table or tables represent solutions of the following equation? Y equals X minus 7. y equals x minus 7. 1 only, 1 and 2, 3, or 2 and 3. Which tables represent the following equation? All right, this is one of those scenarios where you could sit and be super mathy and figure it out, or you could just use a little bit of common sense. Let's do both. So we know that y literally equals the x value minus 7. Now, this method doesn't work as well if it's like 1/2 x plus 4 or whatever. It still works, but it's not nearly as cut and dry. So literally, I can take the x values and subtract 7, and it should equal the y values. Take the x values, subtract 7, and every single one of them should equal the y value if the table matches the equation. So let's test it. -7, that is not a pen. -7 minus 7. Is -7 minus 7 equal to 0? No. If I am looking at a number line and I have 0 and I have 7 and I have -7 and I'm starting at -7 and then I'm subtracting, remember, addition goes to the right, subtraction goes to the left. I am going to be going further into the negatives. So table 1 is already out. But 0 minus 7 is -7. 7 minus 7 is 0. 14 minus 7 is 7. But what I need you to understand is when we graph that, it looks like this. And this side is going to keep going up, which means we've created, for my upper level people, for my high school people, while this is could be like a middle school level problem, it even could potentially drop down in my K6. This right here shows that this is an absolute value function. So yes, this whole section matches, but this whole section doesn't. So we have to check the box on every single one. Table 2, 7 minus 7 is 0. Yes. 14 minus 7 is 7. Yes. 21 minus 7 is 14. Yes. 28 minus 7 is 21. Yes. 2 absolutely matches. So it's not 1 only, and it's not just 3. And I've just figured out my answer. Because if it's not 1, it's not 1 and 2. And it's not 3 only because we just checked out with number 2. So it has to be 2 and 3 only. Do you see? I want you to back up for a minute. Do you see how I just saved you time on your test? That, my friends, is a way that you can solve yourself 30 seconds, 60 seconds, 90 seconds, depending on how long it takes you to solve that table. That is where we want to get to. Table 3, 4 minus 7 is -3, 6 minus 7 is -1, 8 minus 7 is 1, 10 minus 7 is 3. However, I just realized that I don't have the correct answer here. Here's why. I am so sorry. That was not the best way to solve this. And we should have a 2 only here because look at this. Y equals mx plus b. So if I have y equals mx plus b, I know that my b is my y-intercept, and my y-intercept needs to be -7. So while actually it is 2 and 3. I'm sorry. I just lied. Yes, we could get, so if this question was on an elementary test, let's back it up. If this question was on an elementary test, 2 and 3 would be the correct answer. If this question was on a middle school or high school test, we would have to look at the y-intercept being -7, and you would need it to be a -7 y-intercept. And actually, this is not the y-intercept, that's the x-intercept. So the y-intercept actually would be -7. So it would be 2 only if you were taking this, like if this was a high school or middle school test. This problem actually came, now that I'm remembering, this problem came from an elementary level exam prep. And so really we were looking for rules, and the rule was x minus 7. We weren't looking at it through the lens of like a y equals mx plus b. Does that make sense? So if you're looking at it through y equals mx plus b, it would be 2 only. If you're looking at it through the rule of x minus 7, it would be 2 and 3. And so you just need to make sure that you're looking at it through the right lens. And if that was the case, the test would only have one correct answer. So, all right, we have hit the end of our road for today. I will make sure that we have more like problem number 3 from last week next week. I will make sure that I'm addressing geometry and comp 3, and whatever else you think you need help with, let me know in the comment box. I will see those comments later, and I will absolutely address those needs in the upcoming weeks, next week, the week after, all of that. So I look forward to seeing you live next week, and I hope that you all have a great week. I'm going to turn it back over to Dr. A, and I will see you all later. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.